Okay, let's find the derivative of g of t. So here we can find its derivative using the quotient rule. That is, if we have the quotient f of x over g of x and we find its derivative, and this equals g of x times f prime of x minus f of x times g prime of x all over g of x quantity square, where f prime of x is the derivative of f of x and g prime of x is the derivative of g of x. So let's apply the quotient rule. So I write down g prime of t, and this equals, I should now first use the denominator function, which is t plus 4 quantity square, and then multiply with the derivative of the numerator term, that is d by dt of 9 times of t minus 3, and then I put minus. Now I use the first term, that is 9 times of t minus 3, and then multiply with the derivative of the denominator term, which is d by dt of t plus 4 quantity square. And this should be all over t plus 4 quantity square, and this is quantity square according to the quotient rule. So let's simplify this. So this equals t plus 4 quantity square, and then the derivative of 9 times of t minus 3. So this is basically, if we distribute the 9, we will get 90 minus 27, and we should find its derivative. So the derivative of 90 minus 27 is basically 9, because the derivative of 90 is 9, and then derivative of negative 27 is 0. So I just put 9 here, minus, we have 9 times of t minus 3 multiplied with the derivative of t plus 4 quantity square. So here we have to apply the power rule as plus the chain rule. So when we find its derivative, we apply the power rule first. So therefore this becomes 2 times of t plus 4, and then 2 minus 1, which is power 1. So it's just raised to the power of 1. And then find the derivative of inside expression when we apply the chain rule. That is, the derivative of t plus 4 is just 1. So this is basically 2 times of t plus 4. So I put this multiplied with the second term, that is 2 times of t plus 4, and this is all over. This is 2 raised to the power of 2 equals, we just have to multiply these two powers. So therefore this becomes t plus 4 raised to the power of 4. Let's simplify this. If you look at the numerator, we have this t plus 4 as plus this t plus 4 term common in both terms. So I'm going to factor that out. So I write t plus 4. When I factor it, in the first term, I will have 9 times of t plus 4, because this is basically t plus 4 quantity square. So when you divide that by t plus 4, you will get just t plus 4, and then we have this multiplied with 9. So we have to write like this, minus, here when we factor this t plus 4, we will have negative 9 times 2 is negative 18, and then times of t minus 3. And this is all over t plus 4 raised to the power of 4. So let's simplify this. So here, maybe we can just cancel this. If you observe this term t plus 4, we have it in the numerator as well as in the denominator. So here we can just reduce it to 3. This is according to the exponent clause. We can cancel it, or we can reduce it like this. So now we have to distribute this as well as distribute this and simplify. So 9 times of t is 90, plus 9 times of 4 is 36, and then negative 18 times t is negative 18t, and then negative 18 times 3 is negative, I'm sorry, it is positive 54, and this is all over t plus 4 raised to the power of 3. Let's simplify this. So in the numerator, we have 9t minus 18t. These two are like terms. So when you combine these two, we get negative 9t. And then the numbers 36 plus 54, and this equals 90. And this is over t plus 4 raised to the power of 3. So in the numerator expression, I'm going to factor out negative 9. And so when I do that, I will get t minus 10. And this is over t plus 4 raised to the power of 3. And so this is the derivative of g of t, that is g prime of t equals negative 9 times of t minus 10 over t plus 4 quantity cube. And we have written this in the form of a times of t plus b divided by t plus c raised to the power of d. And this means we can identify the a, b, c, and d. So a is this number, that is negative 9. So we say that a equals negative 9, and b is the number inside the term. So b is negative 10, and then c is this number. So we say that c equals positive 4, and d is basically this ray power of t plus 4, which is 3. So we say that d equals 3. So we have identified the values of a, b, and c after we found the derivative of g of t. We will now find the second derivative of g of t. For that, we will utilize the expression for g prime of t, that is the first derivative of g of t, which we have just found. So this is g prime of t. And so we differentiate both sides with respect to t. So therefore, we have to use the quotient rule once again to find its derivative. So we write g double prime of t, which is the derivative of g of t, and this equals I put this denominator expression first, that is t plus 4 raised to the power of 3, and then multiply with the derivative of the numerator expression, that is negative 9 times of t minus 10, and then we put minus. Now I put the numerator expression, that is negative 9 times of t minus 10, and then multiply with the derivative of the denominator expression, that is t plus 4 quantity cube, and this should be all over the denominator square. The denominator expression is t plus 4 raised to the power of 3, and this has to be quantity square. So let's find the derivative for the numerator expressions. So here we have t plus 4 raised to the power of 3, and this is multiplied with the derivative of negative 9 times of t minus 10. So let's find this derivative, negative 9 times t minus 10. First, I distribute this negative 9, so it is negative 9t plus 9t. So we should find its derivative. And so this gives a derivative of negative 90 is negative 9, and this derivative of 90 is 0. So basically the derivative of this expression is negative 9, which I write down here. And then we can multiply this minus. We have a minus and we have a minus. So product of 2 minus is positive. So I can put this as 9 times of t minus 10, and this has to be multiplied with the derivative of t plus 4 raised to the power of 3. So when we do that using the power rule, we put this as 3 times of t plus 4 raised to the power of 2, that is we reduce the power by 1, and then multiply with the derivative of the inside expression when we apply the chain rule. The inside expression is t plus 4, so if we find the derivative is equivalent to 1, and this has to be divided by t plus 4, and here we can multiply these two powers according to the exponent law. So 3 times of 2 is 6. Now let's simplify this. We see that we have this factor t plus 4 quantity square as well as t plus 4 quantity square in both the terms, which means we can factor that term. So I'm factoring t plus 4 quantity square from both the terms. And so when I do that here, I'll be left with t plus 4 times of negative 9 and this quantity is removed. So we will have this product of numbers 931, which equals positive 27, and then multiplied with t minus 10. And this is all over t plus 4 raised to the power of 6. So let's simplify this. We see that we have this factor t plus 4 quantity squared and t plus 4 quantity power 6 in the denominator. So we can reduce this to just power of 4 according to the exponent clause. So let's distribute this negative 9 into the terms inside the bracket. So we get negative 90, negative 36. We also distribute this 27. So it is 27t minus 270, and this is over t plus 4 raised to the power of 4. Let's simplify further. So here we have the like terms negative 90, positive 27t. So when we combine them, we get 18t, and then we have the numbers negative 36, negative 270. So when we add this, we get negative 306, and this is over t plus 4 raised to the power of 4. And in the numerator, we can factor 18. So when I do that, I get 18 times of t minus 17, because 306 divided by 18 is 17. So I don't like this, and this is over t plus 4 raised to the power of 4. So we have g double prime of t, that is the second derivative of g of t, and this equals 18 times of t minus 17. This is over t plus 4 raised to the power of 4, and this is in the form of e times of t plus f divided by t plus g raised to the power of h. Okay, this is t minus f. So which means we can write down e f g h. E is basically this number, so e equals 18, and f is basically this number, that is 17. So f equals 17, and g is this number, so g equals 4, and h is this power number, so h is also 4. So we have determined the values of e, f, g, and h. Let's do question 2. So here we have this function f of x equals 8x power 4 minus 144x squared plus 57, and we should first find c, which is the critical point. So we can find the critical point by setting up this equation f prime of x equal to 0 and solving for x. So let's do that. So first we have to find the derivative of f of x by differentiating both sides with respect to x, and when you do that, we get f prime of x, and this equals we applied the power rule. So this is 8 times of 4x cube. By using the power rule, we put the power in front, that is 4 in front, and write x to the power of 4 minus 1, which is 3. And we now find the derivative of negative 144x squared. So we put the number negative 144, and the derivative of x squared is 2x using the power rule. And now the derivative of 57, which is constant, is 0. So let's put this in simple form. So f prime of x equals 8 times of 4 is 32, x cube minus 144 times 2 is 288 x. Here we can also write down in factor form. So I write f prime of x, and this equals, I can factor 32x, and so I get x squared minus this should be divided by 9. When you divide 288 by 9, we get 9. So it is x squared minus 9. So this is the factored form of f prime of x. Now we have to set this up equal to 0 so that we can find the critical point. So replace f prime of x equal to 0. So we get 0 equals 32x times of x squared minus 9. And we should solve for x. So 32x equals 0, or x squared minus 9 equals 0. And so this gives x equal to 0, and this gives x squared equal to 9. Or when we take the square root on both sides, we get x equals plus or minus 3. Therefore, we write the critical point of this function, that is c equals, we get 0, negative 3, and positive 3. And now we will prepare a sign chart for the derivative function, that is f prime of x, by including this critical points. So I put this number line, and here it is negative 3, 0, and positive 3. So basically we are preparing a sign chart for the derivative function f prime. So we have to put some random values to the left of each of the critical points. Let me copy the f prime of x. I'm going to copy this form, that is 32x times x squared minus 9. So this is f prime of x, and this equals 32x times x squared minus 9. So first we consider this critical point negative 3. We should plug in some random values to the left of this critical point as well as to the right of critical point. So first let me consider the value of x equals negative 4, and this is to the left of negative 3. We should plug this into the derivative function and determine its sign. So when we do that, we get 32 times of negative 4, and then multiplied with negative 4 quantity square is positive 16 minus 9. We should just understand only the sign. We don't need to find the exact value. So 32 times negative 4 is going to be a negative number, and then 16 minus 9 is going to be a positive number. So here we have product of a negative number and positive number, which is going to be negative, and this means this is less than 0. So the derivative function is negative to the left of negative 3. So I mark this as negative. Now we should put some random values to the right of negative 3. So I'm going to consider negative 1. So I plug in negative 1 into the derivative function. So it is 32 times of negative 1 times negative 1 square is positive 1. So it is 1 minus 9. And so this is a negative number, and 1 minus 9 is also a negative number. So here we get a product of two negatives, which is a positive. So the f prime is basically positive to the right of negative 3. So we can mark this as positive, that is till the next critical point. Now let's consider in this interval, that is to the right of 0. So we can plug in positive 1 and determine its sign. So let's plug in positive 1. So it becomes 32 times of 1 times 1 squared is 1 minus 9. This is basically a positive number, and this is a negative number. And so the product of positive times negative is negative. That is in this interval, or to the right of the critical point 0, this is negative. Now let's put some random values next to the right of the critical point 3. So I'm going to plug in x equal to 4. So we will have 32 times of 4 times 4 squared is 16 minus 9. So this is a positive number, and 16 minus 9 is also positive number. So positive times positive is positive. So we can mark a positive sign to the right of the critical number 3. So by the way, we have prepared the sign chart for f prime. And so now we can use this sign chart to determine at what critical point this f prime changes from positive to negative. So f prime changes from positive to negative at the critical point. Clearly, we can see from this sign chart at x equal to 0, it changes from positive to negative. So we see that this is c equal to 0. And this is the only critical point when f prime changes from positive to negative. Now we will determine when f prime changes from negative to positive. So we can see from the sign chart at x equal to negative 3, it is changing from negative to positive, as plus at x equal to positive 3, it is changing from negative to positive. So we say that there are two values of c, that is when c equal to negative 3, as plus when c equal to positive 3, it changes from negative to positive. So these are the two values of c.